Imagine a world where hackers can't steal your data because physics literally won't let them. Where teleportation isn't just science fiction, but a real way of transferring information. A world where the internet as we know it becomes obsolete. That's the promise of quantum internet. Not a faster version of what we have now, but an entirely new kind of internet, built on the strange and powerful laws of quantum mechanics. And if it works, it could reshape cybersecurity, revolutionize communications, and unlock technology we can't even imagine yet. But before we talk about how quantum internet will change everything, we need to understand what it actually is and why it matters. At the heart of quantum internet is a bizarre concept called entanglement. Einstein famously called it spooky action at a distance. When two quantum particles, like photons, are entangled, their states become linked, no matter how far apart they are. Change one and the other changes instantly. This isn't a metaphor, it's real, verified by hundreds of experiments. And it's the key to the quantum internet. Now here's where it gets interesting. Today's internet is built on classical information, ones and zeros. Your passwords, your messages, your bank details, they're all encoded as binary bits, sent through cables and routers, vulnerable to interception or theft. But with quantum internet, we're not sending bits. We're sending qubits, quantum bits that exist in multiple states at once thanks to a property called superposition. And when those qubits are entangled, something wild happens. Anyone who tries to eavesdrop on the information immediately disturbs the system. That's not just a cool feature. It's a game-changing one. It means quantum communication is fundamentally secure. If someone tries to intercept a quantum message, the message destroys itself. The laws of physics guarantee it. This isn't just theory anymore. In 2017, Chinese scientists used a satellite to send entangled photons between two ground stations over 200 kilometers apart. And it worked. No wires. No hackable signals. Just quantum particles dancing across space. So what would a quantum internet actually look like? Think of it as a layered system. You'd still use regular devices, laptops, phones, but they'd be connected to quantum repeaters and routers that transmit entangled particles. These devices don't copy data, they distribute entanglement. That's crucial, because in quantum mechanics, copying information destroys it. This principle, called the no-cloning theorem, is what makes quantum internet different from everything that came before. With entanglement distributed, two parties can now share a quantum key, a secret code known only to them. This is called quantum key distribution, or QKD. It's unbreakable, not just by hackers, not by supercomputers, not even by future AI. If quantum internet becomes global, espionage as we know it ends. But the implications go even deeper. Imagine connecting quantum computers across continents, not through fiber optics, but through entanglement. Suddenly, you've created a quantum network. Each machine doesn't just process data, it becomes part of a quantum supersystem. Problems that would take today's fastest computers thousands of years could be solved in minutes. From modeling complex molecules for drug discovery, to optimizing global supply chains in real time, to breaking encryption that protects governments, quantum networks could reshape power, science, and society. Of course, we're not there yet. Quantum entanglement is fragile. Particles can decohere, meaning they lose their quantum state, if they interact with their environment. That makes long-distance transmission tricky. Scientists are working on quantum repeaters, kind of like signal boosters, to keep entanglement intact over long distances. But it's one of the biggest technical challenges. Then there's infrastructure. A global quantum internet would require new satellites, new ground stations, new fiber networks. Billions of dollars, decades of engineering, and yet progress is accelerating. The EU, China, and the US are all investing heavily in quantum communication. Countries are racing to create national quantum networks like digital arms races. Only this time it's about entanglement instead of nukes. So what happens if one country builds the quantum internet first? It wouldn't just mean unhackable communications. It would mean secure coordination of quantum AI, military strategies, intelligence sharing, and economic systems. Whoever controls quantum internet might not just win a technological race, they might rewrite the rules of global power. But this isn't all doom and dominance. A secure global quantum internet could also unlock a new kind of trust. Imagine voting systems that can't be rigged, financial transactions that can't be spoofed, personal data that literally can't be stolen. We could build a civilization where privacy isn't a policy, it's a physical reality. And maybe, just maybe, quantum communication will lead to something even stranger. Some physicists speculate that quantum entanglement could one day allow for instantaneous communication, not just across Earth, but across space. Real-time links between spacecraft, satellites, even future Mars colonies. We're not there yet, but it's not impossible. Because once you accept the rules of the quantum world, rules where particles can be in two places at once, where observing reality changes it, where information can exist without traveling, you start to see the old limits differently. The quantum internet isn't just about faster downloads or better privacy. It's about rethinking what it means to connect. It's about building a new nervous system for our species, one woven not from copper or code, but from the fundamental fabric of the universe itself. This isn't science fiction. It's quantum reality, and it's already beginning.